If your code looks like this, you're in trouble. You wanted something clean and extensible, a system where you could just, plug in a new exporter or an algorithm, but it turned into a hot mess of if-else statements. Today, I'll show you a simple design pattern that solves exactly this problem, the registry. It's easy to implement, and once you know how it works, you want to use this everywhere. Let's dive in. If you want to learn more about how to design a piece of software from scratch, I have a free guide for you. You can get it at Arjan.Codes/design guide. This contains the 7 steps I take when I design new software. Hopefully, it helps you avoid some of the mistakes I made in the past. Arjan.Codes/design guide. Link is also in the video description. Now, what is the registry pattern? This pattern is a way to avoid hard coding logic like those if-else statements by storing that behavior in a sort of central registry. In Python, that can be a dictionary, for example. And then instead of calling functions directly, you register them under a key like a string or an enum and later call them dynamically. It's like a sort of named plugin map, one that's easy to extend without changing the core logic of your application. If you look at this example, we have an export data function that picks the exporter based on the format, which is a string. Now I could use an enum for that. I kept it to a string also because that maps better to the example that I'll show you after this one. But the problem here is that this is like this chain of if-else statements. Depending on the format, you call a different function. If you want to add more exporters, you're going to add more lines of code here. This function is going to get really long. It's not really a nice design. Right? And by the way, these exporter functions in this particular example, they don't really do anything. They just print a message because it's not really about exporting. It's more about how you patch everything up. And then the main function I call export data with various formats. Now you could say, hey, why don't just call export PDF and export CSV? But that kind of defeats the purpose because maybe you want to be able to select the exporter in a dropdown, for example. And then you want to call that function directly. Now, if we run this example, then this is what we get. See, we get some export results. So how do we change this so that here we no longer have to deal with this if-else statement? Well, we're going to use the registry. Like I mentioned in the beginning, a registry is a sort of central place where you keep track of all of these different things. So let's create something called exporters, and that's a dictionary of strings to export functions. That's a type that I defined here, which is a callable that takes data and doesn't return any results. It's basically the signature of each of these exporter functions. So that is my exporter dictionary. Now, currently this is empty, but what you can do then is you can map the names to the function names. So for example, here we have export PDF. And for good measure, let me actually define this after I actually define the functions. Now, similarly, we can add the other formats here as well, like CSV and JSON, like so. So now we've stored our export functions in a dictionary. And the nice thing about this is that you can take all of these if-else statements that we have here and then basically change it to this. So then we don't need all of this stuff anymore. So as you can see, we now simply pick the exporter given the format, and then we call that. And if we don't have one, then we raise a value error. No more if-else statements. The main function is still exactly the same. Let me run this one more time just to show you. There we go. And if we export to a format that doesn't exist, well, then of course we're going to get an error, as we would expect. But now it's also really easy because of this registry of exporter functions. It's really easy to add another one. So I could create, for example, an export XML. I don't know why you would ever want to export something to XML, but well, here we go, XML. And then I can add another line here that exports my data to XML. For example, there, let's run this. Well, we still get the error, but it's now also exporting data to XML. XML is probably what you should say. I'm Dutch, so I say XML. Doesn't matter. Anyway, the nice thing about this is that I didn't need to change my export data function. The only thing I needed to do was add my particular exporter to the registry. So this is the basic idea of the registry pattern. Now this is not perfect yet because, well, we don't only define the function here, but we also have to manually add it to our exporter dictionary. And this is kind of a low-level thing. And if you have many exporters, well, then this is also going to be a huge dictionary, right? So we don't really win that much by turning it into a dictionary, except we don't have the if statements here, but now we have this very long dictionary. Now, one thing that you can do is actually let your exporter functions register themselves. And you can do that in Python by using decorators. So what I'm going to do is I'm going to import wraps from functools, because that's what we'll need for a decorator function. So I still have my exporters dictionary, but now I'm going to add a register exporter. As you can see, this code is already generated for me. So the exporter, it registers a function for a particular format. That's a decorator, and it simply stores that function into my exporters dictionary. And now, instead of defining my exporters here manually, what I can do is I can go to my export PDF function and I can do register exporter PDF. And again, I have to remember to define things here in the right order. So I'm simply going to do this, and let me also move that up. There we go. So now I can register this as a PDF exporter, and I can register this as well, and register this one as well, and this one as well. Let's run this code one more time. I'm going to comment this out because I don't like getting that error all the time. And now you see we get our various exports. And this is actually a pretty neat setup, because now we have our registry logic, which is basically here. We have the dictionary and a decorator to register an exporter. And when I define my exporter, I can simply use a decorator to make sure that this function is actually registered. It's actually added to the registry. And now this opens a lot of possibilities. For example, I could define these things in different files and then simply use the decorator to register them. I could even make something that scans a directory of scripts and then adds all the functions that are defined in modules in that directory to the registry, which makes it really easy to extend the code. You can basically just add a file to a directory. You don't change anything in the main script, and you have your extra plugin or your extra exporter. And that's a really nice thing about the registry pattern. Now you may notice I'm not using classes and inheritance here. It's not really about how you build this, whether you're doing this with a decorator or with a class that has methods. In the end, it's about setting it up in a way so that it's easy to add these things on the fly. And this is one way to do it in Python. This is actually my preferred way of doing this. Next, what I want to do is show you an example that's a bit more involved. So let's say we have a command line interface that's called textutils that can do stuff with text, like counting words, reversing text, shouting text by turning it into uppercase. And it will also support adding more commands in the future without ever touching the main script. And the example that I have here actually uses the registry for that. Here I have a file registry.py that contains the implementation of the registry, very similar to what I showed you before. Now it's slightly different in that the registry here is a list. It's a list of tuples with 2 strings and a callable. So this is basically the function. And the strings, they are the group that the command line belongs to and the name. So you can do things like text shout or text reverse, group name and name of the actual command. Now this all is very similar, except we simply append the item to the list instead of storing it in a dictionary, because we have both group and the name. Then I also have a get registry helper function that simply returns a copy of the registry, so we can work with it locally without accidentally removing things from the registry. So that's the registry implementation. Obviously, you can improve this in various ways, but for now, this is what we have. Keep it really simple. Now, what I'm doing in the main file here is that I use typer to create a command line interface. And I do that in 2 steps. First, I have a function called load text commands that imports the text module from the commands package. If you look at the actual code, we see that there's a folder structure here. So I have commands, then I have text, so that's the group. And then I have my actions. So we have count and we have reverse. As you can see, I'm using the decorator here to register this command. So this has the text group and the count command. And then it simply splits the text and counts the number of words. What it exactly does is not really that important. And we also have a reverse text where we also register that as a command. So these are basically imported here on the fly, as you can see, by using import module. Now, I also have load plugins. So there is another folder here called plugins. And these are set up very similarly. So these are basically other commands that are sort of extensions to our standard text commands. So here I have shout, for example, that turns the text red and turns it into uppercase. So in principle, there's not really much difference between what is a command and what is actually a plugin. You can move these around. They're implemented in exactly the same way. The main reason I put it in a separate folder is that then it's clear for you as a user where you should put your extensions and that they're different from, let's say, the built-in commands. Now, the final step in the main file is to actually register all of these commands with typer. And that is actually what's happening here. So I'm using typer slightly differently here. I'm not using the decorators. I'm simply registering them directly by using add typer. But the idea is the same. And then in my main function, I'm loading the text command, loading the plugins, registering those with typer, and then running the app. So you see when I run this, then of course I get missing command because I didn't add any commands, but it is a typer app. But now that we have this, I can actually call commands like this. Here I'm counting the text from a simple string, and then I'm getting this as a result. Or here's another example where I'm now reversing text, which is actually a palindrome, by the way. And finally, I can also call the plugins. So in this case, I have my shout plugin, and here is what we get. So this is an example of a more real-life implementation of a plugin system. So if you have some sort of CLI and you want to be able to dynamically add commands to it, this is a good way to do it. Now, to show you that you can actually add commands to this without making any changes in the rest of the code, let me add another plugin. So here, I'm simply going to add a whisper plugin. So I'm going to copy this, call this whisper. And then here, of course, we also need to change the name. And then this is going to be whisper, and apparently that needs to be blue, and we turn text into lowercase. So now I'm not going to shout, but I'm going to whisper. Note that I didn't change anything in the main script. I just added a file to my plugins folder. And then let's also use some uppercase here. And now you see this actually turns it into lowercase, and it has added this plugin dynamically. So this is an incredibly powerful design pattern, and I use this type of thing a lot. Now, in particular, what I like about the registry pattern is that it's a really easy way to kind of group behavior and choose behavior depending on what you need by putting all of these functions into a dictionary. So you don't need to go all the way with the decorator and loading the things dynamically from different modules. You can also use part of this pattern and still benefit from removing all those if-else statements from your code. In summary, what registry allows to do is to add new features without touching the core logic. It's decoupled, the registration happens where the logic is, and it's flexible, it works with many different types of frameworks. And also it's pretty easy to write tests for this because the functions in the registry are just that, they're functions. And the registry can be easily inspected or simplified for running tests. Now, some pitfalls of this pattern is you need to be careful of hidden logic. If you overuse this implicit registration system, then it can be hard to figure out what is actually being registered when you run the code. The order of import matters. If you forget to import a module that registers a command, it's not going to show up. And don't overuse this. I mean, not everything needs a registry, right? Sometimes having an if-else statement is okay. Now, overall, though, it's one of those patterns that is actually really simple, but it's incredibly powerful if you use it in the right place. But I'd love to know how you might use this. Have you built something that could benefit from a registry in your design? Have you used this before in your own code? Let me know in the comments. This video is part of a series I'm doing that focuses on design patterns. If you want to watch more videos covering all sorts of patterns, and there's some real gems in there, check out this playlist next. Thanks for watching and see you next time.